Here I'm just going to prove those results that we saw previously on the previous video for linear coding. So we'll start with the first result, which is if I add a value, k, let's say, to every single piece of data, every single x value in the data set, then what effect is that going to have on my mean? And we decided that that was going to add the same number, that same value of k, onto the mean. So let's now try and prove that. If we imagine how we go about working out the mean, we basically add all the data together. So x1, let's term that the first piece of data, x2 is the second piece of data, x3 is the third, and so on. So we add all of them together and we divide by n. That's what this sigma notation is telling us to do, and that gives us x bar, or the mean. Now let's imagine now that I took the x values and added k to every single member of that set. So that's going to basically be that x1 has had a k added onto it, x2 has had a k added onto it, and so on and so forth. So every single piece of data has the same number being added on. Well, obviously this is addition, so I can write this in any order I want to. So I'll collect all the x values together, and I'll collect all the k values together. Well, if you look at this left-hand side of the fraction, I'm adding all of my x values together and dividing by n. Well, that's just the same as working out the mean. That is the mean. If we take the right-hand side, I'm adding k together, and I'm doing that n times. So this is the equivalent of n multiplied by k. So I've got the mean plus, and then this side here, n times by k divided by n. Obviously the n's will then cancel, and that gives me that by adding k to every single x value, I ended up getting the mean plus that value of k.